universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I am Julie Tomei, and I am joined by Dr. Elena Hyde. Hi, Elena.
Hello, hello.
We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, and on to Western World's Quirks and Quarks and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. Head over to www.yorku.ca/science/observatory and follow the links to OPV, that's online public viewing, and join in the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have on our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on socials. Twitter with our handle at York Observatory, or Instagram with our handle at York U Observatory, and on Facebook at Allan I. Carswell Obs. All of our programs are free, but if you would like to make a donation, you can head over to our website. Again, that is www.yorku.ca/science/observatory, and look for the donate button. We'll be monitoring the chat room for questions, to post content. The current weather in the area is cloudy and rainy and blah. So not so much for meteorites for us tonight, or meteors, I should say, for us tonight. But yeah, how's it going, Elena?
Well, I heard that there was actually a little bit of hail coming down as well.
Fun!
Yeah. So I wouldn't be at all surprised if most of the telescopes in the sort of Toronto, Ontario general area were closed this evening. But if it was clear, you're quite right. We could be looking at perhaps some meteors or some planets. There's all kinds of great things out there. We just can't see them because of the weather. So unfortunate for us. Venus has actually been very good last few nights. So maybe if it's just clear just after sunset, have a look and see if you can catch that bright planet Venus going down in the west after the sun. It's been really quite lovely for several days now.
It has been. Very great. Very shiny. Such wow.
Almost makes you want to go into space.
Almost. I still don't think my body could handle it. So I'm going to stay right here on the Earth. Stare at it through telescopes and binoculars and such.
That's also a good plan.
It's my plan. All the power, more power to people going to space. I'm going to stay put.
I think I would go if I don't know, there was some sort of like older astronaut program for people who couldn't quite pass that first fitness test.
Yeah. The like John Glenn program.
I don't think I could pass his fitness test either, but something below that, the general populace sort of space tourist fitness test. That one I could probably do.
I mean, that eventually, I guess, would be a thing. Like, we're not all fighter pilots going up in airplanes now.
That's true. And I mean, famously, of course, they did have, Canadian William Shatner go up with Blue Origin. And
it's true.
And he had a wonderful time by all counts. Came back very inspired for the planet Earth, actually, which is always nice.
Yes. I hear that happens a lot. Being inspired for the planet Earth. All right. Shall we dive into our space and astronomy history?
Yes, I think we should, because we do have a very space-based program, maybe even more so than usual.
All right, let's do it. What do you have for us?
Speaking of sending things into space, if you wanted, for example, a space telescope, I can get you back to April 25th of 1990, I should say. The Hubble Space Telescope was deployed. And of course, we've heard a lot about the James Webb Space Telescope. Of course, it's beautiful new imaging and lots of James Webb Space Telescope images coming back. But it's worth remembering that the Hubble Space Telescope kind of did it first. Beautiful, inspiring, never seen before images from space. Of course, after it had to get repaired. But it was deployed, interestingly, from the cargo bay of the Space Shuttle Discovery. And it actually has 2 solar array panels, which were sort of deployed with it in the grasp of sort of the Discovery's remote manipulator system, which looks on pictures a little bit reminiscent of Canadarm, of course, on the ISS. And the whole mission was managed by NASA's Space Flight Center, and they sort of deployed and, of course, constructed the observatory, and were, of course, then also responsible for helping with the corrections. And the Hubble is interesting in so many ways. We could talk about, of course, the Hubble Deep Field, and amazing discoveries of Hubble. It is the only telescope that has actually been designed to be maintained in space by astronauts. So if you're very keen on going into space and have quite a handy side, you could have, in the 1990s, been sent up to actually do repairs, upgrades, replacing systems on the telescope, all 5 of the main instruments. So it's had a lot of work done on it by astronauts, which is really unusual because working in space is very, very hard. So deploying it back in April 25th of 1990 is interesting in a lot of different ways. But I think the one that I'll really call out for this show in particular is that it wasn't just sort of put into space any old way. It was actually deployed with the Space Shuttle Discovery. And inside the spacecraft, you had several astronauts who'd come along. So this was part of STS-31. Astronauts Lauren J. Shriver, Charles F. Bolden, Bruce McCandless, Catherine Sullivan, and Stephen Hawley. And it was launched by the Space Shuttle Launch Vehicle. And the Space Shuttle Discovery was part of that Space Shuttle Launch Vehicle. The shuttle was reusable, but it required a long period of refurbishment. So these early launches that we were doing back in the 1990s, it wasn't sort of like a modern rocket that you see now from recent Blue Origin or SpaceX launches. This was a very different kind of launch vehicle. The reusableness of it was maybe not great because it was quite expensive, and every time you used it, it needed a lot of work afterwards. But it was in use all the way until 2011. And interestingly, it could take about 24,000 400 kilograms or so into low Earth orbit. And that sounds like a lot, but when you look at what they're trying to do now with more modern rockets, like the Starship, which was rather spectacularly unsuccessful, and we'll probably talk more about that later, the Starship wants to take maybe even 100,000 kilograms into low Earth orbit. But the space shuttle was doing smaller but regular trips into space for things on the order of 24,000 kilograms all the way until it was sort of discontinued in 2011. So it was operational, this system for launching things into space with these space shuttles. And it's important not to get confused. The space shuttle was attached to the launch system. And so you had components, including, you have your vehicle, which was attached to basically what looks like a giant rocket with 2 recoverable solid rocket boosters and an expendable external tank. So they're all sort of not necessarily stapled, but attached together and launch at the same time. So this kind of launching system was very complex and underwent lots and lots of sort of small changes along the way. And I've heard it said actually that by the time they discontinued in 2011 with Atlantis's final flight, it was actually so complex it almost couldn't have been built again. So it's all part of a really, really interesting history of not just launching things into space, but also how we do that and what kinds of components of those rockets are reusable, what kinds are not. And of course, sending things into space. If you do get your space telescope into space and can talk to it remotely, well, you don't even actually have to go there yourself if you don't want to. But if it's Hubble, you do actually have to have, of course, people to go up and repair it every once in a while, which is really, really fun. So extra props to the Hubble Space Telescope and Space Shuttle Discovery, and of course the entire Space Shuttle launch vehicle, which we don't have anymore, but we're hoping to get a replacement for.
Yeah. I recently listened to an episode of the Smithsonian Side Door podcast that was talking about Hubble and everything that had to happen to fix the blurry vision that it had when it was first put into service. It's really interesting. So anyone who wants to learn a little bit more about that should go check that out.
Yes, and it was, of course, quite the embarrassment to find out that its optical system did have a flawed mirror, because your first light images coming back with real stars being spread over wide areas instead of concentrated into little tiny pixels. That's severe spherical aberration, because their actual outer perimeter was, I believe, too flat. So the way the light reflected did not exactly align. And it's worth remembering as well, if you're going to launch things into space, that's a very dodgy proposition anyways, because it has to be strapped to a rocket. But astronomical instruments are so sensitive and require such precise alignment. It's kind of even a riskier proposition. So fortunately, as you say, they were able to characterize the error and sort of make a correction. But it was fairly embarrassing for NASA.
Oh, absolutely. And fortunately, not just for, astronomers and for everything that the Hubble Space Telescope went on to do, but the Hubble Space Telescope was being looked on as sort of a proving ground for being able to put stuff in orbit and then being able to go there and maintain it and stuff. It was sort of a bit of a proving ground for the International Space Station. So if they weren't able to fix it, we might not have the ISS today.
That's very true. And being able to find a mechanism for humans to work in space and actually do repairs. They did they did have quite a lot of I suppose valuable lessons learned, not just don't make mistakes in your mirror, but also how to do, as you say, how to do repairs, how to do service type missions. And now we know how to do that. That's really, really good. I mean, whether you want to just have a space station or a space hotel or do more complicated construction projects up there in maybe not low Earth orbit, it's getting a bit crowded, high Earth orbit maybe.
Oh, eventually we'll be orbiting the moon and doing these things too.
Yes, Lunar Gateway. Can't wait for it.
All right. Let's move a few years further down the line. We're going to April 26, 1993, with the launch of STS-55. And this mission was also known as Deutschland 2, or D2. It was the 55th shuttle flight and the 14th flight for Shuttle Columbia. It was a multinational space lab flight and ran 88 experiments from 11 nations. The payload specialists on board were Ulrich Walter and Hans Schlegel from the German Aerospace Center. Columbia carried the second reusable German space lab, or D2, and demonstrated the shuttle's ability for international cooperation, exploration, and scientific research. D1 had flown on STS-61A back in October of 1985. The crew worked in 2 shifts around the clock to perform the experiments, and the experiments were in areas that included fluid physics, material sciences, life sciences, biological sciences, technology, Earth observations, atmospheric physics, and astronomy. During the mission, the 365th day in space for the shuttle fleet was marked, as well as the 100th day of flight time for Columbia. D2 marked the first telerobotic capture of a free-floating object by flight controllers in Germany. The crew conducted the first intravenous saline solution injection in space as part of an experiment to study the human body's response to direct fluid replacement as a countermeasure for the amounts lost during spaceflight. Got to trust your co-crew members for that.
Yeah, that sounds more scary than the launch.
Right? They also successfully completed an in-flight maintenance procedure for collection of orbiter wastewater. They participated in 2 amateur radio experiments, SAREX-2 from the United States and the German SAFEX. These experiments allowed students and amateur radio operators from around the world to talk directly with the space shuttle in orbit and participated in a space medicine conference with the Mayo Clinic. Not too bad for a mission that lasted just under 10 days.
Yeah, I mean, it does seem kind of scary, though, because you've got intravenous injections, wastewater in space, and a serious time limit. So, I mean, this mission sounds quite scary. So
yeah, I'd be like, no, thank you. I will not be participating in an intravenous experiment. You can get somebody else to do that. Thank you.
Yeah, this was way before they ever had space coffee. So you wouldn't even be able to get a little coffee afterwards to recover.
Oh man, I mean, I know it's important, but whew.
Yeah.
I get a little jittery when, fully trained nurses are trying to put an intravenous in me,
Yeah, so this is nerves of steel. That's what you need, folks. if you're going into space, absolute nerves of steel.
I also have so many questions, gravity is what gets the saline drip going.
You'd have to have some sort of pressure, of course, in order to make it work. But yeah, it does seem like internal systems being what they are. That's maybe one to read up a little more on.
Yes, I did not read up on it. I will admit, I was just kind of like, whoa, okay.
Just don't read up on it, maybe like before you're gonna have dinner or something, because that's oh dear. And of course,
those are friends, so maybe I just won't read up on it.
That's also definitely an option.
Yes.
And of course, Shuttle Columbia, going up as well. It's worth noting that compared to our last story, the Shuttle Columbia was actually using the same sort of launch system, just with a different shuttle, right? So we had the Space Shuttle Discovery and the Space Shuttle Columbia, and all the other space shuttles. Which, how many are there total now? Some of them have made it into museums. But they all used the same kind of launch system.
All but two.
Yeah.
Yeah.
Yeah, of course.
Yeah.
Lost in accidents.
Yes.
If you get lost in an accident in a space, you don't get put in a museum if you're a shuttle. But yeah, they did have an amazing success rate with those several different shuttles. So even though it took a long time to refurbish and repair them after a launch, they were able to just go launch, and it was expensive. And that probably was one of the reasons why they're like, this is not a super sustainable expense to keep putting out. But it was so incredibly successful, putting up many experiments, of course, putting up the Hubble Space Telescope, participating in Muir, just uncountable. I mean, there's probably a list somewhere, but I couldn't find it. The incredible success of these older, maybe, by today's standards, a little less capable, but really impressive space shuttles and their launching system. It's definitely something I still think about. It's like, it's too bad we didn't just somehow keep it operational.
Yeah, absolutely. Certainly closer to the end of the lifetime of the shuttles, they were focusing on building the ISS and getting that done before the shuttles were retired. But for the beginning portion of their lifespan, it was go up in space and cram as much science into those week and a half long missions as you could possibly do.
Yeah, and it's, you got to wonder if they just kept it running for like 6 or 7 more years, how much bigger would the space station be right now? Anyhow, these are the kinds of thoughts that keep me up.
All right. Well, let's move on to our third item this week. We're moving a little bit back in time.
Yes, and speaking of scary things, I'm sorry, but I do have a slightly scarier one for my This Week in Space and Astronomy History. I'm going to take you away from the Space Shuttle launch system back to Soyuz rockets and April 24th of 1967, when Soviet cosmonaut Vladimir Komarov became the first man to actually pass away during a space mission. His spacecraft actually became entangled in its parachute when he was trying to land. And the Soyuz rockets were, of course, very, very different from the missions that we've been talking about so far. They're more what we think of now as a traditional launch system. The Soyuz rockets were about able to take in something like 7,000 kilograms to low Earth orbit. So it's a smaller vehicle all in. And, this was 1967. So this is about almost exactly 6 years after Yuri Gagarin completed one orbit of Earth, which was actually 12th of April, 1961. And if you don't know about that, well, boy, do I have some news for you. The first human in space. So Vostok 1 was Gagarin's only space flight, and it was quite a moment in history, shall we say. getting started and having that first flight in space was a wonderful jump start to space travel. And of course, the downside was, of course, there was competition being sort of going between the Soviet Union and the United States at the time. But Vostok 1 was launched from Baikonur Cosmodrome on 12 April 1961, and there is still a Yuri's Night celebration. So if you're interested in having a party in April, it's always a fun one to commemorate, because this was the first human that we know of to get into space, and he had a radio communication between the launch control room, and there's even a little dialogue from the moment of the rocket launch, and it was sort of off we go. Very, very exciting, amazing time in history. But these early rockets were very much giant explosions that were contained, and there were of course more accidents, and somewhat laxer regulations all around. But it's notable that although we had the first human in space, and say 1961, it was 6 years later that we actually did have the first sort of space fatality. And this is not including, of course, airplane test pilots who were training, but this was actually for the space mission from Vladimir Komarov. And Vladimir Komarov is a really interesting astronaut, so I definitely recommend people to read up on this a little bit as well. So it's very much an interesting This Week in Space and Astronomy history, because if you don't know about the first person to pass away during a space mission, he had a really interesting life. He was, of course, a test pilot, as so many were in the early space program. But he was also an aerospace engineer, and he then became a cosmonaut. He was the first Soviet cosmonaut to fly in space twice, and he was actually declared medically unfit for training or space flight twice while he was in the program, and continued on anyways. So it was a little bit of a lucky, unlucky kind of space career, shall I say. But he did go through the Air Force, and he was the pilot of Voskhod 1, the first craft to carry more than one human being into space as well. And, he was on the 18th orbit when he attempted his landing. Unfortunately, did not make it. But it's worth thinking about the ones that didn't work as well as the ones that did. And the Soyuz rockets are also really interesting rockets in terms of their technology. They've kind of been sort of, at least to my impressions, were that it was one of the most almost standard ways to get into space for quite a while. And Soyuz, having a little bit of a lower carrying capacity for getting things into low Earth orbit, wasn't necessarily a disadvantage, because you don't always need to take, everything and the kitchen sink with you. So it's a very robust program that with a lot of really interesting history. And they did use the Soyuz to ferry crews to the space station, which we've mentioned just a little bit ago, and getting things regularly up to the space station using the Soyuz as kind of almost a shuttle, going up, especially throughout the 60s. All the way up to, I think, 1971, and they sort of went into an automated sort of Soyuz light vehicle, which was really fun. So they've got a bunch of different Soyuz missions that have all run. I think Soyuz, the last Soyuz was something like Soyuz 19 or 21, depending on how you count it, because Soyuz 21 was when it sort of also got the name of Salyut 5 in 1976. And, very, very, very fun stuff. Just be careful if you're deploying the parachutes, I suppose. And I'll take this moment to say, let's remember Vladimir Komarov when we think about the space program, and when we think about rocketry, because it was, sort of almost today, 1967. He did give his life for our space program. I mean, humans' space program, not necessarily Canada's.
That does not sound like a fun way to go.
Space is really hard. It's worth remembering. It's this is an incredibly hostile environment to humans that we're trying to send people to at very, very high velocities.
Mm-hmm, mm-hmm.
And everything involved with it is just mind-bogglingly difficult. I mean, why did it take us so long to be able to escape Earth's gravity? Because it's very strong.
Because Earth doesn't want us to escape its gravity.
Compared to our little human amounts of strength, Earth's gravity is absolutely going to win, unless you have a very big rocket.
Much power. All right. Well, from one Soyuz mission to another.
But a happier one, I hope.
Yes, this one with a much happier ending. So April 26, 2003, it sees the launch of Soyuz TMA-2. This was a mission to the International Space Station. It was the second for the TMA modification of Soyuz and the sixth Soyuz mission to the International Space Station. The commander was Yuri Ivanovich Malenchenko of Roscosmos, and the flight engineer was Edward Sang Liu of NASA. Liu was the first American to launch as a flight engineer on a Soyuz, and he was also the first American to launch and land in a Soyuz. And this was because of the Columbia disaster in February earlier that year. During his time on the station, Malenchenko became the first person to get married in space on August 10th of 2003. His bride...
Happy news, finally!
Yes. His bride, Ekaterina Dmitrieva, was in Texas, where long-distance marriages are legal. That was the thing I learned this week. Doesn't make for much of wedding night, but it does make for a good story.
Very exciting. And of course, the Soyuz, being used for happy stories is always nice as well. And I did check very quickly. The Soyuz is still, as of this date, the most frequently used launch vehicle in the world. Has not been overtaken by anything yet. So it is been in operation, as we were saying, for a very, very long time. First introduced in 1966 from the Vostok launcher, and it has had over 1,900 flights. And counting. It'll
take a long time for anything to overtake Soyuz.
So whoever wants to break that record better get busy right now, because Soyuz is, and it's much like the space shuttle system, it's so good, and it's had such great success. It has provided an incredible amount of value, and the difference, of course, being that the Soyuz is still in use, so you can still send things via Soyuz.
Yeah, it's hardy.
And
right.
Trustworthy, I think, was the word I was kind of searching for before.
Yeah.
It's a tried and trusted method of getting something into space, and it's just been working, which I really, really admire. I love things that just keep working for decades, many, many, many decades.
Yeah, I can imagine going and seeing it and hitting the side of it and going, they don't build them like this anymore.
Yeah, well, and
they do, because they keep launching them.
They do have a lot of older ones, some components and things like that. And it just reminds me, is like when you find things that are just that sort of good, it's kind of like, why would you ever get anything else? It reminds me more than anything of this. In 2005, I left a 1983 Volvo two-door with 400,000 miles on it in Arizona. And last I heard, it still works.
Nice.
And it's like, it was, and it's just like, yes, solid mechanism. Got to admire that.
Absolutely. All right, folks, you are listening to York Universe, broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Please head over to yorku.ca/science/observatory for chat, questions, content. You are listening to myself, Judy Tomei, and Dr. Alina Hyde. We have just wrapped up our This Week in Astronomy and Space History. And we are now going to give you a reminder. Go ahead, Elena.
Yes, there is one extra quick reminder for this week. So exciting times. This is April 24th. In 2 days, on April 26th, it will be Wednesday, and we are going to do a special Teletube YouTube broadcast starting at 7:30 p.m. Eastern Time with a guest speaker, Dr. Mary Helen Armour, who's going to talk about craters, in craters in particular in Ontario. I believe she's actually got some pictures of some not too far from Killarney Provincial Park. So I hope she brings those as well. It should be a really, really fun guest talk. It will, of course, be recorded, but if you want to come in and watch the live broadcast, 7:30 p.m. Eastern Time over on our YouTube channel, you can get there from the website or just go to YouTube and search for Allan I. Carswell Observatory. Should be a really fun show, so come on by and check it out if you want to, I suppose.
Nice. I lived on the edge of a crater for a few years there.
Craters are great as long as they're not like really current.
Oh, yeah, no, this one's like is several billion years old. That's on the edge of a crater.
A good age for craters.
It is an excellent age for a crater. Yeah. Okay. So let's dive into our news items. Why don't we start with yours, Alina? It's been what everyone's been talking about for the past few days.
Space. So keeping with our theme, our rocket-shaped theme for today, all of these different rockets we've been telling you about. Of course, the Space Shuttle launch system, the Soyuz rockets. There are many, many, many kinds of rockets, but only one kind has recently exploded and made the news this week. And that is, of course, the Starship famous and now newly famous rapid unscheduled disassembly. So this is, of course, the SpaceX Starship rocket, which exploded about 4 minutes after launch on Thursday, after it had been delayed from Monday. So actually last week we talked about how that it didn't happen, and I don't remember if I said it on the show or after the show, but I said I do recall thinking, with all the tests that they still want to do and all of the safety things that haven't quite been met, I don't think they're going to try to launch on Thursday because it'll be too risky. So it did blow up. But they're sort of claiming it's disposable, but I'm not sure I completely believe in its disposableness. It's always sad when you lose a rocket. It blew up at about 127,000 feet over the Gulf of Mexico. Of course, it left a pretty big debris cloud. A lot of people's vans and cars got dust all over them. It actually broke parts of its own launch pad because it was so strong. And people kind of thought, well, this was a really, really big explosion, wasn't it? And the answer is yes, it was. The Starship that exploded, it actually was substantially larger than anything we have been talking about on this show so far. It was much larger than things like the Soyuz or the Space Shuttle launch system. It's actually substantially larger than the old Saturn V's and the smaller Ariane 5s, which we might have time to talk about a little bit later, if we get, depending on how long this story goes for. But this is part of kind of the what's been called the new generation of spacecraft. So 60 years ago, to get to the moon, NASA built the then most powerful rocket in the history of space exploration, the Saturn V. It helped the U.S. win the space race. In 1972, flights to the moon ceased, and the Saturn V was sadly no more. It had an incredibly high launch cost. It was economically sort of unviable. You couldn't use it for any kind of conventional travel, but it was so powerful. Now Starship is trying to take on some of those same challenges that were sort of, I guess, moon-sized challenges is how I would say it. So Starship is not necessarily trying to take on space shuttle-sized challenges or Soyuz-sized challenges. It's really trying to get out there and address the ability to go to the moon reliably, and for that, it needs to be quite large. So if you look at the sizes of these rockets, if you've got the size comparator or there's a great site that's Worlds of the Rockets Past and Present. The Starship physical size is almost double the height of the old Space Shuttle launch system. It's higher and larger and bigger, stronger, faster than the Saturn V. And it has the potential to put not 10,000, not 20,000, not 50,000, but maybe even 100,000 kilograms into low Earth orbit. That is massive. It's absolutely ridiculous. So it's not surprising that it's having a little bit of trouble with some of its tests. So compared to the old Saturn V, this new Starship has these three sort of. It's got a super heavy booster. It's got these Raptor engines, and its propellant capacity is on par. But interestingly, the one thing that people are looking at, and why I think my own opinion about why people are calling it potentially more disposable is the old Saturn V's. If you were to develop them in 2020, the cost would have been something like $50 billion. Ridiculous amounts of money. I can't even comprehend. But the Starship is, divide by 10. So something like 5 billion. And if it doesn't explode, it's fully reusable. So the Saturn V was not reusable. It had 13 launches, but, not reusable. Starship, in theory, reusable, but it's had 0 successful launches. So which one would you really choose? I mean, right now we're in an interesting sort of intermediate area where we're watching the Starship sort of get tested, get developed, and 4 minutes is not nothing. It did actually get off of its launch pad, so there's always that. And if it's successful, this Starship will be absolutely key to a lot of the things that we've been talking about. Problem of the explodingness. So the launch did happen with no one aboard. I'm happy to report. So the Starship rocket has not injured anyone. So this is not going to be one of those sad stories. It had its 33 engine. It's the 33 engine super heavy booster, and you might see some pictures of the launch when it was first going off. Just watching all of those engines ignite is really something. Even from just the video, the Starship has some really interesting design differences versus, of course, the old Saturn V. And one of the things that it's been interesting is, of course, you've also got other things being developed by NASA in sort of competition, but also kind of meant to work at the same time, I think. I'm not sure how much of a competition it is, but of course the Space Launch Systems, or the SLS Back to the Moon NASA systems. So that system has already worked and done a flyby unoccupied, no humans. So the recent success of the first part of Artemis with SLS and friends is really, really exciting, because now we've got potentially 2 options to get back to the moon. And because they have different capacities to carry and slightly different amounts of reusability, there's no reason to my mind why we can't have both of them. But it's a really interesting time in rockets, in spacecraft, and of course, who knows, maybe that moon basketball game I've been wanting to see forever will finally happen.
Yes, in time. It was interesting to look at some of the coverage. It was certainly interesting to watch the explosion, because who doesn't like to watch an explosion so long as you know that no one's being hurt?
Yeah, with nobody on it, it's fine.
Yeah, just kind of whoa, look at that giant thing explode.
So it's a firework, a really, really big firework.
Giant firework, yeah. I think one of the best headlines I saw was why this isn't a big deal.
Yeah, don't take it. Don't be too disheartened, folks.
yeah. And I was like, see, and it wasn't. It wasn't it was in time, right? So it wasn't a specialized space publication. I think people are starting to understand that space is hard, and things are going to go boom once in a while.
Well, I think it helps that the live coverage was also quite good on this, to the extent where a lot of the commentators who were on live were not disheartened, shall I say? I mean, I don't want to say that they were enthusiastic, but some of them were actually quite enthusiastic about the troubleshooting and the knowledge that they were going to gain from this test. And so, this isn't the only chance we're going to get for this rocket. It's going to get a lot more chances. And now we know so much more. Shouldn't we just be excited? And I mean, well, okay, it's always sad to see a rocket not make it, but I think that the, as you say, there's now a little bit of more understanding that we're going to learn from this, and hopefully it will work next time.
Yeah, ultimately we learn more when things go awry, and we build in more robustness. Is that even a word?
Sure.
When those things happen. So, I think in the long run, the Starship's going to be better for the explosion of last week. All right. Shall we talk about Ariane 5 for Juice? Are you feeling thirsty?
Yeah, let's do it, because this is actually really fun, and it shows Starship back to the moon, gigantic freaking rocket. But you don't always need the biggest rocket. So sometimes an Ariane 5 will do just fine. And Ariane 5s are, again, one of these just super reliable launchers. And you want to tell us what Ariane 5s can do?
Sure. It can get a spacecraft with what has to be the most... I mean, they were really trying for this acronym.
Oh, so tortured acronym.
Oh my God.
So maybe the worst acronym I have seen in months.
And astronomy has so many acronyms. This one is terrible. Okay, so the acronym is JUICE. The JU comes from Jupiter. The IC comes from icy. Moons? We're just going to forget that word is there at all. And the E comes from explorer. So JUICE, Jupiter Icy Moons Explorer, of course. It is a 1.6 billion euro ESA space mission. And it launched from the Kourou spaceport in French Guiana on April 14th after an initial delay the day before due to possible lightning. The spacecraft will do a couple of flybys, 3 flybys in all, of Venus and Earth to get gravitational assists on its 6.6 billion kilometer trip. That will take 8.5 years. So the ETA at Jupiter is 2031. So a less powerful rocket doesn't mean you can't get there. It just means you might need a few gravitational assists, and it'll take you a little bit longer. A key milestone was confirmed when JUICE called home after separation from the rocket, confirming that the 90 square meters of solar array had deployed. And the mission is going to study, as the name implies, the icy moons of Jupiter, specifically the Galilean moons, Callisto, Ganymede, and Europa, that are all thought to have large reservoirs of liquid water. So these moons range in diameter from 4,800 kilometers to 5,300 kilometers. And for reference, our moon has a diameter of 3,500 kilometers. Scientists want to know, is there life there? Although Jupiter is quite far from the sun, because Jupiter is so big and has so many moons, there's a lot of gravitational squeezing that's happening there, and that produces warmth and energy that might drive simple ecosystems, similar to the ones found around volcanic vents on Earth's ocean floors. Europa in particular is thought to have an ocean that is 100 kilometers deep. That's 10 times as deep as Earth's deepest ocean, and has the potential for some very interesting chemistry. JUICE will use radar to see into the moons, LiDAR to 3D map the moons, magnetometers to explore electrical and magnetic environments, and other sensors to collect data on spinning particles surrounding the moons, and of course, cameras. It's not looking for biomarkers, but rather gathering information about potential habitability so that later missions can be planned.
Yeah, it's very, very exciting. And you just have to forgive them for the acronym, because this is an amazing chance to go to Jupiter and learn all kinds of stuff about some really critically underexplored objects, in my opinion.
Oh, for sure. I'm really looking forward to it. I like the idea of like, we're going to go explore these three, learn a bit more about them, and then like use those data to figure out, you know, which one is the most interesting one to go study next. Like, and maybe send a lander to. Yeah, because it's going to do just flybys, right, of the moons.
Exactly. And I mean, we've known for a while that we'd need some sort of kind of almost submarine type explorer for especially Europa, because it's literally got a gigantic ocean. And on Earth, the oceans are just teeming with life. So it's just super exciting, but you'd have to get, of course, through that crispy, crunchy outer icy crust as well. So it needs to be explored a little bit more so that we can understand exactly what the crust is doing, and maybe help finalize designs on this some potential submarine or something. And they do have a partial overlap with the Europa Clipper, which is planned to launch next year still, I think.
Yeah, it's supposed to launch next year, and it'll actually arrive sooner because it's launching on a more powerful rocket.
Aha, that's what your rockets do for you. But yeah, the science payload on JUICE is not so tiny, really. It's 280 kilograms. So even though we've been sort of saying, oh, the rocket was small, this is not a necessarily super tiny spacecraft, and it's got a lot of instruments on there. I can't wait to find out what they determined about the radiation environment and the thickness of Europa's ice crust and all kinds of other stuff. Maybe something will pop out of the oceans and wave at us. We get really lucky.
I mean, especially if we want to, send a submarine, got to figure out how thick those ice crusts are. We've got to get through them.
Yeah, well, and it's just so much to learn and try to understand. And if you get a chance, definitely look at some of the existing pictures of Europa, and you can see the ice crust where it's cracked and shifted, and water has welled up from the oceans underneath. It just basically screams, "Come and do more explorations here."
Yeah, so cool. And maybe we'll get some close-up photos of those geyser events. Oh, I'm so looking forward to it.
Absolutely. So you don't necessarily need a big rocket, but it doesn't hurt either.
That's true. All right, everyone. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York Universe. Your hosts this evening have been myself, Julie Tomei, and Dr. Elena Hyde. Stay tuned, because it is Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western Worlds, and Science for the People. You can always connect with us on Twitter at York Universe, and check out our website for show notes, contents, updates, and other information at www.yorku.ca/science/observatory. Thanks for tuning in. Clear skies, and have a good night.
We hope that you've enjoyed
Good night, everyone.
AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license.